Get ready for massive shifts in the AI world. Google Cloud has just dropped the hammer with its 8th-generation TPUs, TPU-8T and TPU-8i, bringing unprecedented leaps in both AI training and inference performance. These new units feature massive memory upgrades and redesigned architectures set to revolutionize how frontier models are built and how AI agents operate in the enterprise. We dive deep into what this means for the future of artificial intelligence infrastructure.
Stop using your finger for notes, sketches, and edits. This Jam-Jake stylus pen gives your iPad a smoother, more precise writing feel with palm rejection so your hand can rest naturally on the screen. It charges fast, works for hours, and comes with replacement tips. Perfect for school, work, or creative projects. Check the link in the comments to grab it on Amazon.
Next up, we're looking at how Google is supercharging the user experience with generative AI right in your daily life. Google has unveiled exciting new features for its mapping and geospatial apps, including Maps Imagery grounding, letting you use generative AI to create realistic scenes in Google Street View just by typing a prompt. Plus, they are transforming data analysis with aerial and satellite insights, shrinking weeks of work into mere minutes for users analyzing satellite imagery in Google Earth. We continue our deep dive into the hardware revolution as we look at Google's dual strategy for its new accelerators. The TPU-8T is built purely for training frontier models, promising to cut development cycles from months down to just weeks with incredible scale and efficiency. Meanwhile, the TPU-8i is laser-focused on inference, featuring massive on-chip memory and new collective acceleration engines to crush latency for those critical AI agents. And finally, we break down the entire infrastructure play. We explore the powerful Virgo Network, which allows the TPU-8T to scale up to 1 million chips across data centers, and the incredible efficiency gains, including double the performance per watt. This is a game changer, and we'll tell you exactly what this means for your business. Stay with us, because this is the future of AI infrastructure. Google Cloud has announced a major generational overhaul of its AI infrastructure, introducing 2 new tensor processing units, or TPUs, designed to significantly advance both AI model training and inference capabilities. The new hardware, TPU-8T and TPU-8i, feature substantial performance and memory optimizations, including larger high-bandwidth memory and a redesigned machine learning architecture. The training-focused TPU-8T is approximately 2.8 times more powerful than the previous generation TPU Ironwood, offering 121 FP4 exaflops of AI compute. Google Cloud anticipates this will drastically reduce the development lifecycle for frontier models, enabling new model training in weeks rather than months. Each TPU-8T pod can accommodate up to 9,600 individual chips, boasting high bandwidth and scale-out capabilities. Addressing the growing need for consistent, low-latency inference, the TPU-8i has been specifically engineered to run AI agent swarms with minimal latency and 0 idle chips. Each 8i TPU includes 384 MB of onboard SRAM for on-chip short-term memory. Furthermore, each 8i server incorporates double the CPU hosts, utilizing in-house Axion CPUs based on ARM designs to enhance overall inference performance. A critical networking innovation is the introduction of BoardFly, a new network topology replacing the older 3D torus design. BoardFly focuses on increased chip connections and reduced network diameter, which Google Cloud claims results in up to a 50% latency improvement for the TPU-8i, addressing the previous limitation where the network prioritized throughput over latency. Google Cloud CEO Thomas Kurian stated that the split into specialized hardware, one optimized for training and another for inference, is a natural evolution, mirroring strategies seen by competitors like Oz. This hardware is part of Google Cloud's AI hypercomputer, which integrates specialized compute, storage, networking, and software. To support massive-scale training, Google Cloud has integrated its infrastructure with Pathways, a DeepMind system that efficiently splits inference tasks across TPU pods. For training, the combination of Virgo Network, Pathways, and JAX allows Google Cloud to connect over 1 million TPU-8T chips across multiple data centers for single, massive training clusters. For TPU-8i, Virgo Network can reduce network latency by 40% compared to Ironwood. In terms of efficiency, the new TPU family achieves double the performance per watt compared to Ironwood, a key metric for managing the rising costs associated with deploying numerous AI agents. A challenge Microsoft predicts will require significant infrastructure and energy efficiency gains by 2028. This efficiency is already showing tangible benefits, with firms like Citadel Securities reporting a 30% reduction in trading system costs. Google Cloud emphasizes that these innovations were developed over 2 years based on internal discussions regarding future AI bottlenecks, focusing heavily on power efficiency as a core constraint. The introduction of these specialized chips and infrastructure solidifies Google Cloud's position in providing leading-edge, highly optimized AI solutions. Google has significantly boosted its mapping and geospatial applications with new generative AI features specifically tailored for enterprise users. Announced at Cloud Next in Las Vegas, these updates introduce enhanced visual and data analytics capabilities to the Google Maps platform. One major addition is Maps Imagery grounding, which empowers enterprise users to utilize generative AI to create realistic visualizations within Google Street View. By simply entering a prompt into the Gemini Enterprise Agent Platform, users can conjure detailed scenes, such as movie sets or construction sites, inside Street View, with the option to animate them using Veo. Furthermore, Google is revolutionizing satellite data analysis through the Aerial and Satellite Insights feature. This new capability allows users to analyze imagery stored in Google Cloud's BigQuery data warehouse, drastically reducing analysis time from weeks to mere minutes. To accelerate geospatial analysis for businesses, Google is launching 2 new Earth AI imagery models. These systems are trained to automatically identify specific objects in imagery, including bridges, roads, and power lines. This development eliminates the need for businesses to spend months training proprietary AI systems from scratch. These advancements underscore Google's strategic push into enterprise geospatial AI. The Earth AI platform is already in use by partners such as Airbus and Boston Children's Hospital for critical applications, spanning environmental monitoring to disaster response. Google stated that these AI updates unlock entirely new possibilities for businesses, data analysts, and urban planners. Google has launched a dual-track strategy for its AI accelerators, unveiling the TPU-8T for training and the TPU-8i for inference at its annual Cloud Next conference in Las Vegas. This strategic split aims to maximize performance and reduce operational costs across the entire lifecycle of large language model deployment. The TPU-8T, designed for training, boasts 8th-generation tensor processing units that are up to 2.8 times faster in training and deliver 80% higher performance per dollar for LLM inference compared to previous Ironwood TPUs. This development is part of a broader effort to optimize hardware for specific workloads. Google is pursuing specialization by developing distinct accelerators for training and inference, a trend recognized earlier by competitors like Amazon Web Services and NVIDIA. While NVIDIA has optimized its Blackwell Ultra generation for inference, Google is taking a more integrated approach, also moving away from x86 processors in favor of its in-house ARM-based Axion CPUs for TPU hosting. Under the hood, the TPU-8T maximizes floating-point throughput by tweaking the mix of vector, matrix multiplication, and sparse-core embedding accelerators. Each accelerator features substantial specifications, including 216 GB of high-bandwidth memory, HBM, capable of 6.5 TBs bandwidth, and up to 12.6 petaflops of 4-bit floating-point compute. For inference, the TPU-8i prioritizes memory bandwidth, which is critical for autoregressive workloads where model weights must be streamed frequently. The TPU-8i trades some raw flops for a larger on-chip SRAM cache and a higher capacity memory pool, helping to keep the key-value cache resident on the chip. Furthermore, it replaces sparse cores with a collective acceleration engine, CAE, to reduce collective communication latencies, which is crucial for efficiently handling modern mixture of experts, MOE, architectures. Scaling efficiency is another cornerstone of Google's strategy. The TPU-8T utilizes optical circuit switches in its network fabric, enabling connections up to 9,600 accelerators in a single unified pod, stitched together by the new Virgo network to support massive compute domains. This network topology allows for a flattish two-tier all-to-all structure, capable of connecting up to 134,000 TPUs per data center. Google claims these advancements, combined with a managed Lustre storage system delivering 10 TBs of aggregate data, will ensure training-optimized TPUs operate at a 97% goodput, minimizing downtime from failures or stalls. The inference focus is further enhanced by the boardfly topology, which uses dragonfly-like arrangements and optical switches to cut maximum chip-to-chip latency from 16 hops to just 7 hops, significantly improving performance for reasoning models. Both the TPU-8T and TPU-8i are slated for general availability later this year on Google Cloud Platform, bundled within the provider's full-stack AI hypercomputer platform, providing end-to-end solutions for deploying and training LLMs at scale. Google has unveiled its 8th-generation tensor processing units, the TPU-8T and TPU-8i, at Google Cloud Next 2026 in Las Vegas, marking a significant strategic shift by separating training and inference workloads onto distinct hardware. This dual-chip approach aims to deliver substantial leaps in performance and efficiency, positioning Google Cloud as a compelling alternative to NVIDIA's infrastructure. The rationale behind the split is rooted in the fundamental differences between the two workloads. Training demands maximum computational power and scalability, while inference requires low latency and high efficiency for real-time AI agents. The TPU-8T is engineered specifically for training frontier models, promising to reduce development cycles from months to weeks. A single TPU-8T superpod can now house 9,600 chips, delivering 121 exaflops of computing power and 2 petabytes of HBM, featuring the new Virgo network fabric capable of scaling to 134,000 chips within a single data center. Focusing on inference, the TPU-8i addresses the demands of deployed AI models. It features a pod configuration of 1,152 chips and enhanced memory capacity, 288 GB of HBM combined with 384 MB of on-chip SRAM to minimize latency. Furthermore, the TPU-8i boasts doubled chip-to-chip bandwidth of 19.2 TB/s and a 50% reduction in network diameter through the boardfly architecture, alongside the adoption of Axion ARM processors. Google claims these new chips deliver twice the performance per watt and an 80% better price-performance ratio compared to the previous Ironwood generation. Reliability is paramount for the TPU-8T, which is designed for over 97% goodput, utilizing the Virgo network for automatic failure detection and rerouting without human intervention. While the performance metrics are impressive, the ultimate challenge for Google is convincing organizations to adopt this infrastructure. Google emphasizes deep integration across silicon, networking, software support, including native support for JAX, PyTorch, and VLLM, and bare metal access. However, the chips are exclusively available through Google Cloud, creating a strong integration lock-in. Although Google supports existing tools, the comprehensive, managed ecosystem is designed to significantly reduce the incentive for customers to migrate to NVIDIA infrastructure. Both the TPU-8T and TPU-8i are slated for general availability through Google Cloud later this year.